Back. Tonight we're talking about session 2, evidence for God. Last time we talked about the cosmological argument. Tonight we're going to be talking about the teleological argument. So if you remember last time, a lot of the source material, so I want to go over some of the reference material you can use, you can get. This book is great. I Do Not Have Enough Faith to Be an Atheist by Dr. Norman Geisler and Dr. Frank Turek. What I like about this book is that it's written at a layman's level, in the sense that it tells you that about the scientific discoveries, but doesn't tell you in a way that you can't understand it. It's very easy to read. For example, it talks about Edwin Hubble discovering how the universe is expanding. And so it gives you that as a conclusion, that universe discovered this thing and how it affects that, how we can mathematically now calculate the universe retreating, back from a single point if it's expanding out. Right. But if you need some more scientific behind it, like how did we know that it's expanding, this other book here, The Creator and the Cosmos by Hugh Ross, this is a great book too. It covers a lot of the same points of the previous book, but it also covers all the rebuttals that you get from various atheists and scientists, and also goes into the science behind it, like due to the red shift of the planets. All right, what's the red shift? And why does red mean it's expanding? Why does blue mean it's contracting? So the Creator and Cosmos will give you more of the scientific formulas and scientific formulas behind that. So kind of another level up of reading if you're interested. Then we have the Creator series, which I like. It's from Dr. Chuck Missler. Dr. Mark Eastman also was on a couple of the tapes. The Creator series is from the khouse.org, Koinonia House, and it's audiobook series. It's not a written book format, but it's great to listen to in the car while you're driving. One of the great references is the Divine Watchmaker. Kind of applies to some of the things we're talking tonight, and some of the things that we'll be talking in the next section as well. So 3 great sources of material, and I'll give you some other references at the end of the session. So last time we talked about what is truth. Does God exist? All right, and the first point we made was the cosmological argument, that the universe had a beginning, that everything that has a beginning has a cause. The universe had a beginning, therefore the universe had a cause. Right? This tonight we're talking about the teleological argument, that the universe is designed. Next section will be about the design and origin of life, also going into evolution. And then the next one after that would be about the moral law. So the first kind of half of the series that we're doing, this 9 to 10 part series, is around proving there's evidence for God. A lot of this outline is kind of based loosely on the I Do Not Have Enough Faith to Be an Atheist book. And then the second part of the series, the last kind of 4 sessions, is kind of explaining the evidence to why we believe it's the Christian God and not the God of Islam or not God of another religion. Okay? And again, my goal here is just to give you the evidence and let you come to your own conclusion. Right? Don't believe anything I say. Just do your own research to anything you hear to that. We will end the session with Q&A like last time. We will be monitoring YouTube and Facebook, right? YouTube and Facebook. This video live stream is also out on Vimeo and a couple other sources, I think on Twitch as well. But we're only going to be monitoring the YouTube and Facebook channels for any questions you have. All right, so let's review from last time. A quick recap of last time. So last time we talked about why do you believe what you believe? Right? Professor James Sire has great 4 buckets, right, that he says, and that all your beliefs come from. Right? You have your sociological reasons, right? It's because your parents told you. It's because your friends told you. It's because society told you and culture told you. Right? This is really important in today's time, right? For all the things on social media and all the things that we read and we just instantly believe to be true. But does that make something true? Right? Does that make something true? Right? And I think that if you think about it, the answer is no. Right? Because your parents told you, society told you, culture told you, doesn't mean that it's true, but it's why you believe what you believe. Then there's psychological reasoning. It brings me comfort, brings me peace of mind. It gives me meaning or purpose. It gives me identity or hope. Right? I believe in God because it gives me peace of mind. Right? That's a psychological reason. But does that make it true? Right? It's why you believe what you believe, but that does not mean that it's true. You might believe something because of religious reasons. The scriptures told you, or the pastor told you, the church told you, the rabbi told you. Right? But then you have religions with conflicting scriptures. Right? So that doesn't mean it's true either. Right? That doesn't mean that something's true. So the last bucket here is a philosophical reasoning behind it, right? We're looking for something that's consistent, that's coherent, that has no holes in it, right? Philosophy itself is coming to a logical conclusion based on the data and the evidence, right? So philosophical reasoning is like looking at the data, looking at the evidence, right, to see if something is true. Some truth comes from science, but not all truth comes from science, right? And then we look at the data and we make interpretation. And we dove into this last time about the law of non-contradiction. So watch the first session. It's up on the YouTube channel. And what we learn is that all truth is absolute, right? All truth is absolute. That means it applies to all people at all times for all places, right? For all cultures. Truth is absolute. Right? I had, after the last session, I actually talked to a friend, and they told me, well, you know, Fred, I believe that there's more than one truth. Right? And if you think about that, and if you paid attention to the last session, you realize that violates the law of non-contradiction. You have to be able to apply the claim to itself. Right? If there's more than one truth, that means there's a truth out there that says there's only one truth. Right? And so it violates itself. Right? It's violating the law of non-contradiction. There can't be more than one truth. Right? Because that would violate itself. We talked about deductive logical reasoning as an example, how we come to conclusion that something is true. Right? So here was an example of a logical reasoning using deductive logic. If 1 and 2 are true, then 3 is. If 1 and 2 are true, we can show that 1 and 2 are true, then 3 is true. That's the conclusion. All humans are mortal. John is a human, therefore John is immortal. Right? That would be a true statement if 1 and 2 are true. When you talk to people and discuss with people, they'll give you a logical statement. It sounds true, but you have to realize that logical statement does not tell us if something is true or not if our premises are incorrect. I'll give you an example of that. All men are four-legged reptiles. Dave is a man. Therefore, Dave is a four-legged reptile. That is a logically valid statement, but it's not true. Why? Because 1 is not true. Our premises are not true. So if 1 is false or 2 is false, then 3 cannot be true. Right? And so we went into the cosmological argument, and we showed that everything that has a beginning has a cause. The universe had a cause, or the universe had a beginning, therefore the universe has a cause. Right? Leading atheist scientists admit a beginning. Almost everyone now believes the universe and time itself had a beginning at the Big Bang, right? And that's Stephen Hawking, who's leading atheist. His colleague, Alexander Vlinkin, says, with the proof now in place, cosmologists can no longer hide behind the possibility of the past eternal universe. There is now no escape that they have to face the problem of a cosmic beginning. He uses the word proof. Scientists do not use the word proof unless they have overwhelming substantial data to back that up. And then he says that they have to face the problem of a cosmic beginning. Why? Because now they know that there was something that caused it. Right? And they don't want to admit that it's God, and they don't want to say it's God, so now they have to come up with other ideas and other theories of what caused the beginning. Right? And that's the problem that they face. If you believe there is a God, there is no problem, because it makes sense. Right? But if you're trying to argue for against God, then it is a problem, because now you have to come up with some other reasoning for that. We went through the rebuttals last time. Again, you can watch the recording from the last session. So SURGE, right, the acronym that Dr. Frank Turek uses in his book to easily remember the science behind why the universe came into existence, right? The second law of thermodynamics, right? The S stands for second law of thermodynamics. The universe is winding down, right? The law of entropy. Right? The universe is winding down. It's losing usable energy, right? So we know that the universe had a beginning due to the second law of thermodynamics. The universe is universe is expanding. We know that the universe is expanding, and we can calculate it coming back, starting from a single point of nothingness, right, Due to the theory of the universe expanding the Big Bang, we then discovered the radioactive afterglow, right, from the Big Bang, right? We were able to detect the heat signatures that were created because of the expansion of the universe, right, to prove that Big Bang. From that, the G stands for the galaxy seeds. We were able to show that galaxies needed a very small infinitesimal amount of heat differences in the afterglow in order for galaxies to form. And we talked about that one. And then E for the Einstein's theory of relativity. Space, time, and matter are all interconnected. One cannot exist without the other. And they all came into existence at the same time, right? Which means there was no such thing as time before the beginning of the universe. The universe came into existence time came into existence at the moment the universe came into existence. Right? And so we showed last time that everything that had a beginning had a cause, right? This is our deductive logical statement. The universe had a beginning, therefore the universe has a cause, right? And so what's that first cause? Right? And atheists don't dispute this. Atheists agree with this. So they come up with other reasons why the universe had a beginning. But whatever it was had to be timeless, had to be outside of space-time, right? Because time came into existence with the beginning of the universe. And whatever the cause is had to be spaceless, right? Not part of our space. Right? There wasn't space here before the universe came into existence. Space itself also came into existence. All right? It has to be immaterial. It has to be outside of our universe, and therefore it's not of material making. It's got to be unimaginably powerful to be able to create this universe, and super intelligent also to be able to create the universe the way it did. And it has to be personal. Why does it have to be personal? Because there was nothing before. Nothing existed, right? And so this first cause had to make a choice to create something, right? To create something. And so it's a personal. Right? It sure sounds like a God. That's what we talk about, God. Whatever this is, that's what we're saying is God, as evidence for God. And we ended with, if there is no God, then why is there something instead of nothing? Why is there a universe instead of nothing? There was nothing before, why is there something? Either no one created something out of nothing, or someone created something out of nothing. Right? Which one's the more reasonable? If you take your worldviews out of it, if you take your biases out of this, and you just look at the data, which is the more reasonable statement. Right, so that was our first point of evidence, the cosmological argument. Tonight we're going into the design of the universe, the teleological argument, right? Talking about the anthropic principle, which we'll go over. And then, like I said before, we'll talk about design of life and evolution next time, the moral law, and those will be our 4 major arguments for why we believe there is a God. So, teleological argument. Teleological argument is just a nice way of saying the universe appears to be designed. Right? Universe appears to be designed. So our deductive logical statement that we're trying to show tonight is that every design had a designer, which we know through observation of life and of living, that everything that's designed has a designer. You find a watch on the ground, it's designed. We don't believe it just came there naturally. You have a nicely designed garden. We know there's a gardener, right? As verified by the anthropic principle, we know beyond a reasonable doubt that the universe is designed. That's what my goal to show you tonight, the evidence for. If we can prove that to be true, then the conclusion is true. That means, therefore, the universe had a designer. So let's talk about the anthropic principle. The anthropic principle really just means that the universe is highly fine-tuned for human life to exist. Right? That's the anthropic principle. That the universe that we live in is finely high-tuned for us to exist here in the universe on Earth. William Paley in 1818 he's a philosopher, and he philosophizes and says, if you find a watch on the ground, right, what do you think? Do you think that watch, over millions and millions and millions of years, naturally came together on its own and formed and created a watch? Right? No, you wouldn't think that. It kind of sounds absurd. But you would know that there's a watchmaker, right? You would know that there's a watchmaker because it was intricately designed. And the watch is superiorly less complicated than the universe, than human life, right? So we're going to look at the universe looks designed and life looks designed. Richard Dawkins, leading atheist, says the appearance of design is overwhelming, right, in his God Delusion book. He said there's no explanation for it in physics, right? No explanation for it in physics. Maybe the multiverse theory explains it, which relies on luck, right? He doesn't know why, so they come up with the multiverse theory, which we'll talk about later, why that's not the case. Stephen Hawking, right, leading atheist. If the expansion rate, so here's some of the data behind it. Here's where we start talking about some of the design elements. If the expansion rate of the universe was different by 1 part in 1,000 million a second after the Big Bang, the universe would have collapsed back on itself or never developed galaxies. Right? If the universe expansion rate was different than 1 part in 1,000 million. Another way to put it, Jeff Zenrick and Zerink and Hugh Ross, 1 part in 10 to the 122nd, right? Which is hard to imagine, right? We're going to talk about big numbers. They're hard to imagine these big numbers. What would that be like, 10 to the 122nd? That would be like 1 billion pencils, all simultaneously positioned upright on their sharpened points on a smooth glass surface with no vertical supports. That'd be the probability of 10 to the 122nd. What's the probability of that? 1 billion pencils all standing up on their points. Right? That's 10 to the 122nd. Right? That's one parameter of the universe that would have to be exact in order for us to be here as life. Gravitational force. If altered by more than 1 in 10 to the 40th, the sun would not exist and the moon would crash into the earth or shear off into space. Right? 1 to 10 in the 40th. Now, the galaxy is not measured in inches, right? So I need 2 volunteers to kind of show this example. 2 volunteers. So I got 1 volunteer, and I got another volunteer coming. So I got a tape measure here. I want you to take this tape measure, and they're going to go off camera, which is fine, and then the other volunteer can take this one. And I'm going to hold the middle here. And I want you to stretch it across as far as you can across the whole room. All right, so you're stretching across the tape measure, across the whole, we're in an auditorium right now. All right. All the way, keep going all the way to the wall. How many feet we got there?
54 feet, 6 inches.
All right, about 54 feet stretched across the auditorium. So 10 to the 40th. The gravitational force, if measured in inches, would have to land within 1 inch here and not deviate in any direction in order to be 10 to the 40th. Now, this tape measure doesn't go far enough. You would have to then stretch this tape measure to get truly to get 10 to the 40th, an example. You have to stretch this tape measure to the width of the known universe. All right, think about that. This tape measure is stretched out across the width of the known universe, and the gravitational force would have to land in 1 inch and stay there. 1 inch to the left, 1 inch to the right, we cease to exist. All right, thank you guys. Stretch across the known universe. You can let go. Yeah, it's crazy, right? That's 10 to the 40th. Right, we're dealing with large numbers here. You can see down the bottom, I put 10 to the 40th and all the zeros behind it. But it would have to land within 1 inch, and any other direction, life ceases to exist, as we know it, everywhere. How about the Goldilocks zone? You might have heard of the habitable zone. All right, scientists named this the Goldilocks zone. How far away can a planet be from its primary star, so the Earth from the Sun, and support life? Right? It's in a small, narrow window. So Earth. If Earth was just 2% farther from the Sun, right, the planet would be too cool to sustain efficient water life cycle. If the Earth was 2% closer to the Sun, the Earth would be too warm to sustain an efficient water cycle. Right? The Earth is in the perfect place it needs to be, distance away from the Sun in order to support life. Jupiter's distance, right, from the Earth. Right? Jupiter's like a galaxy. It's like a vacuum cleaner. All the comets and all the asteroids that come towards the Earth, Jupiter sucks them all in because of its gravitation, because of its gravity. If Jupiter's distance is greater, right, too many asteroid and comet collisions would occur on Earth. If Jupiter's distance was less, Earth's orbit would become unstable, right, and Jupiter's presence would too radically disturb or prevent the formation of Earth. The axial tilt of the Earth, 23.5%. If it deviates too much in either direction, the temperature differences would be too great. Right? I'm just going over some of these parameters. You change one of these parameters, it affects everything else. Earth's rotation, 24 hours. If it was longer, the temperature differences would be too great across the globe. If it was shorter, the jet streams and the average wind speeds would increase too much to sustain life here on the planet. Iron quantities in the oceans and soils. If smaller, quantity and diversity of life would be too limited to support advanced life. Right? We are advanced complex life. So maybe there'd be some microbes and microbials. If very small, no life would be possible at all. And if larger, iron poisoning of at least advanced life would result. So there might be some microbes, but advanced life we wouldn't be here. Humans wouldn't be here. Earth's design, the size, shape, and mass and location of our galaxy. If either one of those is altered in any direction, we cease to exist. We cease to be here. Cease to be here. The sun's distance from the center of the galaxy, If closer, galactic radiation would be too great, stellar density would disturb the planetary orbits, and we'd have the wrong abundances of silicon, sulfur, and magnesium relative to the iron in the planet for us to sustain life, right? If farther, right, we'd have the same issue. Quantity of heavy elements would be insufficient to make rocky planets, and we still have the wrong mix of silicon, sulfur, magnesium to iron to the planet for us to survive. The sun's size, the sun's mass, if less, right, the range of planet distances for life would be too narrow, meaning that Goldilocks zone would be way too narrow to sustain life. Tidal forces would disrupt planet rotational period, right? So if tidal forces affect the rotation of the Earth, we already saw that the rotation would also prevent life. So you start changing one parameter, and it starts changing another thing, and then that changes another thing, right? And it's a cascading effect of changes, right? Scientists have put all these parameters into simulations, and they tweak these things, and everything they adjust affects everything else, and life ceases to exist. Again, if less, there'd be too great the ultraviolet radiation, right, would be too great for plants. If greater, the mass was greater, the luminosity of the star would change too quickly, and the star would burn too rapidly. How about the color of the sun, right? Color of the sun. If redder or bluer, photosynthetic response would be insufficient to sustain life. All right, what about the moon? Right? If the moon's size or the mass was different, if too small, right, we would have inadequate ocean tides. The planet's rotation rate would not slow down fast enough to make advanced life possible. Again, it affects the rotation of the Earth. Right? If too large, if the moon's mass is higher by 2%, the moon's mass would destabilize the tilt. Right? That needs to stay in a certain tilt of the Earth, and ocean tides would be too great, causing too much erosion and disruption in the continental shelf life, right? Life ceases to exist, right? The distance from the Earth to the moon, right, affecting the gravitational interaction with the moon, right? If greater, tidal effects on the ocean, atmosphere, and rotational period would be too severe. If much greater, the axial tilt variations would make life impossible. Right now, it would start tilting the Earth and too much. If less, again, it affects the axial tilt and stability. We wouldn't be able to stay stable with our axial tilt. And if much less, right, then we have the orbital changes would cause too much climatic instabilities, and again, life would cease to exist. How about the surface gravity on the Earth, right, which is the escape velocity? If stronger, the planet's atmosphere would retain too much ammonium and methane. If weaker, the planet's atmosphere would lose too much water. Right? Thickness of the crust, of Earth's crust. If thicker, too much oxygen would be transferred from the atmosphere to the crust, and the volcanic and tectonic activity necessary for continental buildup would be too weak, so we wouldn't have the continents we have. If thinner, there'd be too much volcanic and tectonic activity to sustain life. How about Earth's magnetic field? If stronger, electromagnetic storms would be too severe, right? Too few cosmic ray protons would reach the planet's troposphere, and we wouldn't have adequate cloud formation. If weaker, the ozone shield would be inadequately protected from the hard stellar and solar radiation, and then time between magnetic reversals would be too brief to maintain a long term for maintenance of advanced civilization. You change one of these parameters, human life ceases to exist. In most cases, all life ceases to exist. The albedo, the reflection of the Earth or the planet. If greater, we'd have an ice age, right? If less, we'd have a greenhouse effect. Oxygen quantity in the atmosphere. If greater, plants and hydrocarbons would burn up too quickly. If less, advanced animals would have too little to breathe. Ozone levels in the stratosphere. If greater, surface temperatures would be too low. There'd be insufficient long wavelength ultraviolet radiation at the surface for life-critical biochemistry to operate. If less, surface temperatures would be too high, and there'd be too much deadly ultra radiation at the planet's surface. Right? I don't expect you to remember all that. What I'm trying to give you is the science behind just some of the parameters of the design of the universe. Right? That's just some of the ones that affect Earth, some of the ones that affect the solar system. The universe seems highly fine-tuned to support human life. All right? And we're not done. The atom, let's talk a little bit about atoms. Electromagnetic force that holds atoms together has to be balanced. Right? If any of these are not in the right spot, all life, everywhere as we know it, ceases to exist. The ratio of electron mass to proton mass has to be balanced. The nuclear force couldn't be more than 4% strong and 10% weaker. Life ceases to exist as we know it. Chemistry ceases to exist as we know it. If neutrons were 0.138% more massive than a proton, life wouldn't exist. If the neutron was just plus or minus 0.1% more or less massive, life wouldn't exist. All right. Stephen Hawking says, the remarkable fact is that the value of these numbers seem to have been very finely adjusted to make possible the development of life. Right. Now, I went over 27 parameters with you. Right? Just gave you examples of 27 of the parameters. Here are some of the other ones. Here's a list. Some of the fine-tuned parameters of the universe. Right? This list here is 150 parameters. 150 parameters that if you change any one of these parameters, human life ceases to exist, and most of the time, all life ceases to exist. Right? You change any of these parameters in any direction, life ceases to exist. Right? And it has a chain reaction affecting other things. So changing one actually ends up changing a bunch of them, and life ceases to exist. Right? So you're just an example of 150 various parameters that have been confirmed by science as needing to be exactly where it's at in order to sustain life. Back in 1966, we knew of 2 fine-tuned features. Right? 1995, we were up to 26 fine-tuned features. As science just gets better and better and we discover more and more, we end up discovering more and more and more features that support a designed universe. Currently, we're at over 1,000 fine-tuned features in the universe, right, to support life. If you change any one of these parameters, life ceases to exist. Any one of them, right? No life of any kind anywhere. It's like a huge dial board or a huge control board where everything is perfectly adjusted at just the right parameters in order for life here to exist. So we've talked about some large numbers, right? Gravitational force, 10 to the 1 and 10 to the 40th. We showed the ruler example, right? Stretching the universe across the known universe, stretching the ruler across the known universe, right? And you have to be within that inch. Expansion rate, 1 to the 10 to the 122nd. We talked about the billion pentals standing upright on their points. Let's look at a smaller number. How about 10 to the 17th? Right? What's the probability of 10 to the 17th? You know that 10 to the 17th is the number of seconds in the history of the universe? Think about that. 10 to the 17th, if the scientists are right, and that the universe is 13.7 billion years old, 10 to the 17th is the number of seconds in the known universe. That's a huge number. And yet scientists like to throw out these probabilities of 10 to the 40th and 10 to the 122nd. So I'll give you an example of 10 to the 17th. Well, here's an example. Imagine filling up the state of Texas, the whole state of Texas, 2 feet deep with silver dollars. Right? So you cover the whole state of Texas, 2 feet deep with silver dollars. You take one silver dollar, you mark it special, right? You toss it into the pile. You put on a blindfold. You then equally shuffle all the coins, silver dollars, so that that marked silver dollar could be equally be anywhere, right? Equally be anywhere. You shuffle it, you have your blindfold on, and then you walk out across the state of Texas. And you stop randomly and you reach down and you pull out. The chances of it being that marked dollar is 10 to the 17th. Right? That's 10 to the 17th. Right? And you got numbers here like 10 to the 40th, 10 to the 122nd. Let's do another one. How about 10 to the 149th? Right? 10 to the 149th. This one's a little harder to imagine, but make a ball using all the atoms in the universe. Make a ball using all the atoms in the known universe. Make a ball. Make a ball for every atom that exists in the universe. Right? Then do that for every second that the universe has been in existence, and have all those balls, and then reach in and pull out the right ball. That's 10 to the 149th. Right? It's just staggering, these numbers, right? 10 to the 149, it's just staggering. And I go over this for a reason, because some of the other numbers you'll see are larger than this, right? Are bigger than this. Or I should say smaller, because it's based on probability, but you'll see that. So what I find interesting, is that a lot of times you see NASA and you see on news and articles, oh, we found an Earth-like planets, right? Potential life here, planet. Or the K2-118b is one of those planets, right? Where if you're just reading the headlines, you're like, oh, an Earth-like planet, so we could live there and sustain life there. This is amazing. Then maybe there's life there. Right? If you look at the K2-18b exoplanet, it's 8 times the mass of the Earth. We could not live on that planet. Humans could not live on that planet. It's 8 times the size of the Earth. We wouldn't be able to sustain the gravity. That's just one parameter, right? It's not around the right type of sun. There's lots of other parameters that would affect. We could not live there. Now, maybe in the right conditions, maybe there's microbes and there, but humans could not live on that planet. Right? Then you have the Kepler 1649c. Right? They like to say this is an Earth-like planet, and it kind of looks like Earth. It's 1.6 times the size of Earth, so it's close in size, right? But what they don't tell you when you dig into it, it doesn't get enough light, and it's in the habitable zone, doesn't get enough light, and it's orbiting a red dwarf star. That means the ultraviolet radiation would be too great to sustain human life. We could not live on this planet, right? All the other parameters don't line up. It matches like 2 or 3 of the 1,000 parameters that are needed, right? And that's not to say what's the likelihood that we have just the right quantity and ratio of elements on that planet. There are trillions of stars available for study, right? Only 3,618 planets have been studied so far. 90% of them are eliminated immediately due to the reflectivity of the planet, due to the albedo of the planet. Right? That takes out 90 of them. Star mass and distance from its parent star eliminates 99.9% of those. Now that's just 2 factors. Now add all the other parameters, not just the ones I told you about, and not just the 150, the list that I showed you, but over the 1,000 parameters, right? That must be fine-tuned to support long-lasting microbial physical life. Just microbes, right? The probability is 1 in 10 to the 556. Right? Remember how big those numbers are I mentioned, right? 10 to the 149. That's 10 to the 17. You're talking 1 in 10 to the 556. Right? That's what that looks like. 1 in all those zeros. Right? That's basically impossibility, practically. That's a very high, or very low probability chance of that happening. So FDA, monitors our food, right? And so they monitor a lot of these elements that we have in food: chromium, molybdenum, selenium, vanadium. Right? These are poisonous to us in the wrong quantities. Right? Here's a chart of a bunch of other elements. The ones with asterisks you probably can't see, right? Those are poisonous to us as well. What's interesting about these elements, if you look here on Earth, and you look at the ratio of these elements, like the iron that I mentioned earlier, they're all just the right ratio to sustain human life here on Earth. If you look at the Milky Way galaxy, the galaxy that we're in, and you take and science has looked at the galaxy around us, right? These ratios are completely different. All right, you have 65 more times of titanium. You have 9 times more of vanadium. You have 5 times of chromium. You have 3 times more magnesium. You have 50 times more of fluorine, right? It's complete. The ratios are so off that it would not sustain human life, right? Not sustain human life. And then you go to apply this to, all the other planets that we tried to discover. The probability of microbial life lasting for at least 90 days in an environment is 10 to the 333rd, right? A huge number. Microbial life lasting for at least 3 billion years, 10 to the 556, right? That's the number I mentioned earlier, right? It is highly improbable, right, to find life elsewhere, right? And it's even more improbable, right, to sustain human life. Intelligent physical life maintaining a global high technology civilization, right, human life, us humans, probability 10 in 1,000 to the 32. The tool I used to create those zeros on the slides doesn't even go that high. Right? I think it maxed it out 999. I couldn't even use the tool I was using to give you the zeros to show you how many zeros that was. It's so high. The chance of finding a life-supporting planet with 100 billion trillion stars in the observable universe. The probability of finding a single planet capable of supporting physical life is less than 1 in quadrillion, 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 quadrillion. Hopefully that's the right amount, quadrillions, right? That's the chance of finding a life-supporting planet. And I find that interesting because you always see in the news, like, oh, we have a potential life planet here, we have a potential life planet here, we have a potential life planet here. If you look at the news and NASA and science, it seems like there's life-supporting planets lots of places, right? Lots of places. I found a study that was concluded last year, funded by NASA. So if NASA funded the study, they want there to be, life-supporting planets. That'd be awesome if there was. And, and the sci-fi in me, I like science fiction, I like fantasy, I love science fiction, I love science fiction books. I love the idea of being able to go out into space and to other planets, I like Star Trek, I like Star Wars, I like all that stuff. The idea of it it's cool, it brings me comfort, right? For psychological reasons, I would like it to be true, right? But that doesn't make it true, right? A new study concluded last year. So what they did was, which is interesting, there has not been a study of could human life be supported on other planets. Every time they say a life-supporting planet, they're talking about microbes, bacteria. They're never talking about human life when they say that, right? So a study was actually done and concluded last year. This is the first time physiological limits of life on Earth have been considered to predict the distribution of complex life elsewhere in the universe, right? Basically saying, that's the first study they've done to see if human life could exist on other planets. The conclusion was that I think showing how rare and special our planet is only enhances the case for protecting it. As far as we know, Earth is the only planet in the universe that can sustain human life. Right? This was funded by NASA. Study concluded last year. You can look up the article. I have the links there. Right? But they've concluded that there's no other planet that could sustain human life. The universe looks like it's been designed for us to live here as humans on the Earth, the entropic principle. So there's some rebuttals to the design of the universe. Right? There's a rebuttal that atheists like to say, well, it's only because it's observable, meaning only because we're alive here at this moment and that we're able to observe this designed universe. Because if there was another universe, we'd be dead, and so we don't really know if that's true. And it's a very strange argument. But there's an example, right? So let's say you're in front of a firing squad. You have 10 marksmen up on they're going to shoot you, right? And this is John Leslie's firing example, which I like. There's 10 marksmen that are about to shoot you. On the count of 3. 1, 2, 3. They all fire their guns. And you're still alive. All right? It's not, well, because I'm not dead. I'm only alive because I was here to observe that I didn't die. Otherwise, I'd be dead and I wouldn't be able to prove that that the universe is designed or that I'm still alive. Right? That's not the right question. The question is, if all 10 marksmen shot and missed you, either they're all fired blanks or they missed you on purpose. So what the real question is, who wants me alive? Obviously, somebody wants you to live, right? Somebody contrived this to go off in a way that you wouldn't die, right? That's what we're really saying. It's not that we're not saying the fine design of the universe is not. We're not saying because it's highly improbable that there is a designer. We're saying that it's more improbable that you would have got a universe that doesn't support life. So why is there one that does support life? Right, another example that Dr. William Craig Lang likes to use, which I'll give you another one. So atheists might say, they like to use a lottery example. Well, it's highly improbable for you to win the lottery, but somebody wins, right? 1 in a million or 1.1 a million, whatever it is. It's highly improbable for you to win, but somebody wins. And that's not the right argument, right? They're not understanding the right argument. A more accurate analogy would be, let's say you have a billion black ping pong balls, right? All mixed together. Black ping pong balls, a billion of them. And you take one white ping pong ball and you put it in the mix and you shuffle it equally, you shuffle it around, right? Now, you're going to reach in and pull out a ping pong ball. If it's a black ping pong ball, you die. If it's a white ping pong ball, you live. If you reached in and pulled out a white ping pong ball, would you think that you did that by chance? Or would you think the system is rigged? Right, that's the question. Now, not only do you have to do that one time, you have to do that 5 times. Pull out the white ball 5 times. If you did that, you would know that the system is rigged. It's not about the probability of there being a white ball. It's the probability of you picking the white ball, right? It's not about the probability of picking the white ball. It's the question of why was the white ball picked in the first place? Why was a white ball picked versus a black ball, right? It's the improbability that whatever universe exists, it would be a life-permitting universe versus it would be a life-permitting one versus a life-prohibiting universe, right? Is that the impossibility or the improbability that if any universe was created, and it was created randomly, it's more likely to be a life-prohibiting one than it is to be a life-permitting one. Going back to the Richard Dawkins that I mentioned earlier, right? He says the appearance of design is overwhelming. He says it about the universe, and he says it about biology. He says it about the universe, and he says it about biology. There's no explanation for it in physics, right? Physics is highly fine-tuned. It's order of the universe. We can take a man and ship him to the moon and know exactly how to land him on the moon, right? Physics is order. Where did physics come from? It's not a natural force, right? Where did physics come from? So what does Richard Dawkins like to say? Since the universe seems designed and biology seems designed, but the universe seems designed, he said it's the multiverse theory, right? We think it's the multiverse theory, which relies on luck, which I'll talk about in a second. And its ultimate rebuttal is, well, then who made God? Right? Which we've talked about, right? The uncaused first cause. But that's the best argument he has. It's an idea that it's an idea based on luck, or it's just an argument of, well, then who made God? Right? Ignoring that the universe is designed, right? It must have had a designer. So there are 3 reasons for why this is possible. There's 3 reasons why the universe could be designed. Right? So which one's more plausible? It could be physical necessity. Right? Some might say, well, it's physical necessity. The universe must be light permitting. The values couldn't be anything else. Gravitational force could only be in that one spot and couldn't be anywhere else. Right? Is that plausible? You're telling me that all those 1,000 parameters have to be that way, right? You're saying that a life-prohibiting universe is impossible? Is that what we're saying? Because that's what it's saying. That a life-prohibiting universe is impossible. So a universe could have been randomly created and it been possible to be life-prohibiting, right? It's far less likely. It's far more likely that you have constants and quantities not determined by the laws of nature. Right? There's no evidence and no reasoning to say that fine tuning is necessary. Right? Looking at the constants, the universe constants, like the gravitational force, there's no scientific evidence that says that fine tuning is necessary and has to be there. Right? It could be something else, and there's no evidence to show that it couldn't be something else. So physical necessities is out the window. Then we have chance, right? Chance. We got really lucky. Out of billion ping pong balls, we pulled out the white ping pong ball, right? Scientists use the word chance when they don't know, right? There is no chance in science. There's cause and effect. And so when we use the word chance in science, it's because we just don't know, right? There is a cause. We don't know what it is, right? And so then you have the multiverse theory. Multiverse theory is that there's something that's cranking out universes. This is why the multiverse theory was created, the multiverse theory. Because we know the universe had a beginning, We know that it's designed, right? So atheists say, well, it's a multiverse theory. That means there's something that's creating all these universes, like a machine creating a bunch of universes, and it's creating so many universes and spitting out so many universes that eventually it spits out our universe, right? The random chances and manipulation or however the machine works, it spits out our universe, right? And so that would account for the beginning, and that would account for the design. But one, the creator and the components for the multiverse theory, and the creator says even that had to have a beginning. Even the multiverse and all the universes and the thing cranking out the universes had to have a beginning. Right? So it doesn't get away from having a beginner. It doesn't get away from having a God that create the thing, right? But the multiverse theory, and still the machine itself, that still has to be designed. What kind of machine cranks out a bunch of universes? Right? Someone's got to design that, and to crank out a bunch of universes that are also designed. Right? That's even, if anything, that multiplies the need for a designer. You need even more design and to have a multiverse theory. And the multiverse theory is not detected, not observed, not measured, or proved. It's complete made-up theory. There's no scientific evidence behind it. Right? There's scientific evidence for multiple dimensions. Right? We can prove that through science. There's zero scientific evidence for multi-theory. It's just complete. It's just something that somebody made up and likes the idea of. And it's interesting. I like to watch Marvel movies and the Avengers and the DC movies, and I like those type of movies. And a lot of people like to watch those. And you'll see throughout the Avengers and the DC movies, they have the multiverse, right? And it all makes sense to us, and it's all it makes sense. You have a multiverse. You have different heroes of different versions of the same hero. Multiple Spider-Mans across the multiverse. All right, and so in society, we give these movies and we show that the multiverse theory, and it all makes sense, and we kind of accept it as yes, that's a possibility. That's completely true. It's great for superhero movies. It's great for comic book movies, but there's no scientific evidence behind it. Yet some people I talk to think it's a fact. They think like, oh, the multiverse theory, yeah, that's scientific. That's scientific. Like, it's not. It's never been detected, never been observed, never been measured, never been proved. There's nothing to support the theory for the multiverse theory. It's simply an explanation to get away from having the creator and designer of this universe, even though you still need a creator and designer of the multiverse. So we're left with the third one is design, right? Which is the best explanation that fits. It was designed that way. The universe is designed this way. Over 1,000 parameters designed this way. I have one slide here just to show back to the multiverse, right? If we had a bunch of universes spitting out, right? The little graph at the bottom shows all the little triangles of all the various. We would have a bunch of universes, and there'd be some order to some of the universes. But our universe is so ordered, it's staggering, right? It's like off the chart ordered. Right, which wouldn't make even if the multiverse theory was true, it wouldn't even make sense. The only theory we're left with is, right, last one is the design. Right? It's the best explanation that fits. The universe was designed this way for us to live here, for us to be here on Earth. There's some arguments of the God of the gaps, right? God of the gaps, if you hear that or someone tries to rebut that, that's simply saying when we don't know something, we insert God, and then later we find out what the real cause is, and then people make fun of us because we inserted God, right? This is not a God of the gaps theory. This is not a God of the gaps of I don't know. This is observed. If I see a painting, I might not know who painted it, but I know there's a painter. If I see a design, I don't know why they painted it or how it got there, but I know there's a designer. Right? This is not a God of the gaps theory. So a common sense, so we have Fred Hoyle, astrophysicist, right, cosmologist, director at the Institute of Astronomy of Cambridge. He says, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, and that there are no blind forces worth speaking about in nature. The numbers on calculates from the facts seem to be so overwhelming as to put the conclusion beyond question. Paul Davies. There's more. He's also a physicist, Templeton Prize winner. There is for me more powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. Our impression of design is overwhelming. So I would argue that we've proven number 2, the anthropic principle. All right, every design had a designer. As verified by the anthropic principle, we know beyond a reasonable doubt that the universe is designed. Right? We're talking about over 1,000 various parameters that have to be in the right spot, otherwise life ceases to exist. Human life ceases to exist. And to think that it can't be any other way is silly. It was more probable that there be a life-prohibiting universe than a life-giving universe. Therefore, the universe had a designer. And who's that designer? Right? We believe that's evidence for God, for someone that designed the universe along with creating the universe. So session 1, we showed you the beginning of the universe, the cosmological argument. Session 2, the design of the universe, the teleological argument. And we're not done, right? That's just 2 points. Next session, we'll talk about design and origin of life, and we'll talk about evolution in the next section. And we'll also talk about, in the 4th section, the moral law. So again, some good references. I do not have enough faith to be an atheist. If there's a book you're looking for, or someone that you're having some doubts, read this book. And I recommend you reading this book. Creator in the Cosmos, if you want some more scientific information. And if you believe there's a God already and you're of a Christian background, I recommend the Creator series because it comes from that perspective. Some YouTube channels, some good YouTube channels for apologetics and other good references. Look up Cross-Examined. They're on YouTube. Got a lot of great materials and short videos you can watch and good Q&A, good questions and back and forth, and you can probably find something there where somebody's asked the question that you have. Right, Dr. Craig videos, Dr. Craig Lang's got a lot of great material, and also check out K-House, the K-House channel, and of course the Calvary 813 channel, but we don't have a friendly URL, so you have to look that one up. And that's it. Time for Q&A. So check YouTube, put them on YouTube, put them on Facebook, and they will pop up on the screen here. All right, looks like we have some questions already. So you want to come up or?
So does intelligent design?
No, I have them here. I wasn't sure if you wanted to come up and answer or whatever. All right, so does intelligent design mean that evolution is not possible? So that's a good question. So we'll talk about this in the next section. If evolution, let's just start with this. If evolution is true, that does not mean there's not a God. Right? It does not mean there's not a God. If evolution is true, that does not disprove a creator of the universe. That does not prove a designer of the universe. If anything, if evolution is true, you still need a designer for the evolution. You still need that designer. You still need that creator. So evolution itself does not disprove God. Now, what we will show in the next session is that all the science points. Now, when you say evolution, we have to say, well, what do you mean by that? If you mean microevolution, we agree. If you mean evolution within a species, we agree. Every species we've scientifically discovered within their DNA strands has all the data and information to create variations of that same species. What the science does not show is across species, across kinds. Right? You can't get a cat from a dog. Right? That's what the evidence shows, that science evidence shows. So intelligent design does not mean that evolution is not possible. If evolution was true, that would just make it, you still need a designer, you still need a creator. How do beliefs so hopefully that answers your question. So again, we're monitoring the YouTube channel and we're monitoring the Facebook channel, so feel free to put your questions there. How do beliefs about creation impact the rest of theology? So I'll have to infer, since you're not here kind of to get a little follow-up. So how do beliefs about creation impact the rest of theology? To me, they don't, right? If there's some Christians that believe in evolution, there's some Christians that believe in a young universe, Christians that believe in an old universe. If we find out tomorrow that it wasn't the Big Bang and it was something else, you still need a creator, you still need a designer, right? None of that affects the theology of believing in a cause outside the universe, and none of that affects, if you're looking at a Christian God, none of that affects the message of the Christian Bible or that religion. How do beliefs about creation impact the rest of theology? So I'm not sure 100% how to clarify that question. I'm not sure if I've answered it, because I'm not 100% sure what you're asking there. Third, let me go to the next question. So, you've proven there is a beginning. How old do you think the earth is? That's a good question. Now, whatever I tell you is my opinion, and I could be 100% wrong. I'll give you my theory. This is my personal belief, my theory. This goes back to, if the Bible is true, right, and I'll show you the evidence for Jesus, I'll show you the evidence why I think the Christian Bible is true. So if the Bible is true, if God makes Adam in the Garden of Eden, he makes Adam. How old is Adam when God makes him? Right? He's not a baby. He's not a fetus and growing into a baby and then grows into a man. God makes Adam, and I bet if you were to be there, you would say, oh, here's Adam. He's in his mid-20s. He's in his mid-30s. He's instantly that age, right? But he's only a minute old. But he comes with all the history behind all that. He looks like he's been around for 20 years, right? If you think about when Jesus turns water into wine, right? If he was to turn water into wine, and then you were to have a winologist come and a wine specialist come look at this wine, what would they say? This wine's been aged for years. This is the best wine I've ever had. What did they say in the Bible? The best wine we've ever had, right? It's been aged for years. God just made it 5 minutes ago, right? And so I believe that the universe appears to be old, but that it's not that old. My personal belief is that the earth is maybe, we're looking at under 100,000 years. Maybe it's 10,000 years old, the universe, maybe it's 50,000 years old. My answer doesn't matter, and it doesn't change the belief, doesn't change that there's a God, doesn't change Christianity in any way. It's just my belief is God made the universe, but he looks older because he made it that way. Hopefully that answers your question. All right, any other questions? Again, YouTube, Facebook, feel free to throw out a question. We'll give that a couple minutes. Any questions in here? It's very quiet in the room. And again, if you watch the whole session, I appreciate the time online. In next session we'll talk about origin, design of life, and evolution. So we'll go more into the evolution next session. We'll also have Kelly speaking, I believe. So I'll be presenting half of it, and then you'll see Kelly presenting the other half of it as well. Any other questions? All right. Well, then we'll wrap that up. I'll take that as a wrap up. Hopefully I've answered your questions. And I appreciate your time. Thank you guys very much, and we'll see you next month.